Hey everyone, this is going to be 10.8. It's going to be on volume again, except this is going to be on volume of pyramids and cones. So first we're going to start with the volume of pyramids. So the volume of pyramids is going to be very similar to what we did with prisms, except there's going to be a 1/3 in front. And I'm sure you've learned this before, but I hope you've learned what the 1/3 means. And if you haven't, I'm just going to discuss it quickly. And if you still don't understand it, just ask me in class and I'll be happy to help you. So the 1/3 comes from it being 1/3 of the base prism it comes from. So in this case, it's going to be a rectangular base. And so if it went all the way up, this would be a rectangular prism. So a rectangular pyramid would be 1/3 the volume of a rectangular prism. That's the idea. So if you can kind of see, it'll fit in there. These are 3 rectangular pyramids, just slid their vertex a little to the right and left and whatnot. But we can actually put those into their rectangular prism nicely, and it would give us 1/3 of that. It's the same thing with a cone. A cone will be 1/3 of the cylinder. And so you can see kind of here, it's the same idea. Say in this picture, it says all the water is in the cone. And if we transfer the water, see they have the same base. They have to have the same base, of course. So the base is the same. So we transfer the water from the cone to the cylinder. And when we're done, how much of the cylinder's volume is filled up? You can see it is 1/3. It's 1/3 of the volume. And so if we transfer back, there we go. And if we transfer it back, it's still 1/3. And this is the same thing that would happen with a pyramid and a prism that have the same base. Okay, the prism would be 3 times the size, at least in terms of volume, of the pyramid with the same base. Okay, so that's the idea. So let's go back now and do some of these problems. So basically what we're doing is we're just finding the regular prism volume like we normally would, with its base. So we find the base, ding, 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 multiply by the between the bases. Let's imagine this was the base, ding, 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 whatever, up here. And then we realize, oh no, it's a pyramid. So there should be a pyramid here and a pyramid here as well, but there's not. So this is why we take 1/3 of it. So let's do it. So we take the volume as we normally would of a pyramid, a prism. So we take our base, doink. That would be 10 times 11. We multiply it by the distance to the other base, which would be up here. And then they have to be perpendicular, remember. So luckily they gave us this, times 16. So if this was a prism, this would be perfect. Except it's not. It's a rectangular pyramid, which means its volume is going to be 1/3 of a normal prism. And that's basically the idea. So we do the normal prism, and we just take 1/3 of it. And so when we do that, it's going to give us 586.67 inches cubed for our volume of this rectangular pyramid. Cool. Number 2 is a similar idea. Number 3 is a little bit more challenging. So we still have our rectangular base. In this case, it's not rectangular. What is it? It's a square. So it's still rectangular, but more specifically a square. So it's going to be 14 squared times the difference, let's do x, the perpendicular height to the other base, so that's going to be here. But do we have that? No, they didn't give us that. So we don't know that. So we still have our 1/3, but we're looking for this. We're looking for this. What is the height? There's a trick. We can do it by doing a right triangle here. So they gave us the slant height. Thank goodness. And now we know that the height, or the distance between the bases, in this case there's no base up here, but we imagine there was, like we would a prism, and then we take 1/3 of that prism. So we're looking for this. We know the hypotenuse is 25. Do we know this though? We do, because it's a square. The vertex is going to be right in the middle, so it's going to be half of 14. So half of 14 is just going to be 7. So this is going to be 7. So it's going to be 7 squared plus h squared equals 25 squared, which means h squared is going to equal 576, which means h is going to equal 24. So nice, we have our height, 24. And we're done. Nice. So our volume is going to be 1,568 feet cubed. You would just have to recognize that, which is a little bit more challenging. All right, number 4. Let's do, let's do some more. Let's do a couple more examples with this. So in this case, it's not a rectangle, it's a triangle base. So it's going to be a triangular prism we're working out, and then we take a third of that. So it's 1/3 of our normal volume for triangular prism. So we would normally do the base times the height. So the height they give us is perpendicular to the base. That's 10. Good. And then we have to find the area of the base. Luckily, they gave us perpendicular to the base of 7.5. So 7.5 times the base, 12 times 1/2 as well. So this is going to be actually 1/3 times 1/2 times 7.5 times 12 times 10, which is going to give us 150 millimeters cubed. Looks good to me. Let's see, let me take a second look to make sure I didn't make any arithmetic mistakes. Nope, looks good. Okay, so there's number 4. Number 5, a little bit challenging as well. Let's do it though. Okay, taking the volume, it's going to be 1/3 of what we would normally do for a triangular prism. The height they give us, 19. Whew, nice. We need to find the area of the base now. You can see this is the right angle, so this is the 14. We need this now. So how do we find that? You guessed it, Pythagorean theorem. 14 squared plus x squared equals 22.1 squared. X squared equals 292.41. X equals 17.1. So it's going to be 1/2 times 14 times 17.1. The reason is because the base and the height have to be perpendicular. There we go. And so our volume here, this is number 5, is going to be 758.1 meters cubed. There we go. Number 6, last one for pyramids. This is going to be a triangular pyramid, which is going to be 1/3 of a triangular prism. So 1/3 of a triangular prism. So triangular prism, we find the area of the base times the height. They give us the height, 16. That is going to be the difference between where the other base would be and the base we're going to find. So now we have to find the area of the base, which is going to be 1/2 times, now what? It seems like we got a equilateral triangle here. So we need to find the distance from one of these vertexes. So, maybe it's only half of it is 10, or is no, the whole thing's 10. Yeah, so we are looking for this guy. We're looking for this. We're looking for the height here that is going to be perpendicular to one of the bases. It doesn't matter which we choose. So what you should know is each angle in a equilateral triangle is a 60, 60, 60. Which means we have a 60, 90, 30 triangle. Oh man, so 30, 60, 90 triangle, that's x, 2x, x square roots of 3. So our 60 side is what we're looking for. Our 30 side we know to be what? 5. because it's going to be half of the 10, right? So it's going to be 5. And then our hypotenuse is going to be 5 times 2, which is 10. Boom, we already got that. And our height is going to be 5 square roots of 3. There we go. So our height is going to be 5 square roots of 3 times our base, which is 10. Cool. And that's it. So our volume is going to be, after we do all that, 230 times 9, 230.93 centimeters cubed. And there are your pyramid examples. Now cone is the same thing, except what is our base going to be every time? A circle. So we take the volume, it's going to be 1/3 of a cylinder. We showed that in the volume example. So we take the area of the base times the height. And the height in this case is 17. Area of the base is going to be pi 9 squared. That's the radius. And when we do that all out, we're going to get 1.99 yards cubed. Yards cubed. Okay, there's number 7. Number 8, similar, except they give us the diameter instead of the radius, so you just divide 5 by 2.5. Number 9 is a little bit trickier. So the volume is going to be 1/3 of the whole cylinder, except we don't, and then to find the volume of the cylinder, we take the distance between the bases, that we don't know, times the area of the base. The area of the base is going to be pi, the diameter is 27, so half of that, 13.5 squared. And then we have to find h. So you can see in 3D, this is going to give us that. This is going to be 13.5. We need to find h. So that is going to be the Pythagorean theorem again. 13.5 squared plus h squared equals 22.5 squared. So this is going to be a calculator one. So we get 13.5 squared, that's 182.25. 22.5. Oops. 506.25. And so h squared is going to be, let's see, 324. And so h is going to be the square root of 324, which is 18. There we go. Equals 18. So the difference between the bases would have been 18 if it was a cylindrical prism. And then we take 1/3 of that because it's a cone. There we go. So we get our volume to be, after we put all that in, 3,435.33 kilometers cubed. Yay. Okay, so here we go. Application problems. They're always fun. A cone has a volume. Oh, it gives you the volume. If the height of the cone is 8, find its radius. All right, so we know our volume is going to be 1/3 times the area of the base times the height. So it gives us the volume. It says 1,309 equals, the height of the cone is 8. So pi r squared times 8. We're just solving for r here. So we divide by 8 or we multiply by 3, whatever we want to do first. Let's multiply by 3. We get 3,927. 3 times this. The 3 and the 1/3 cancel out, and then we have to do it the other side. And that's where we get 3,927, and that gives us 8 pi r squared. Just bring the 8 to the front. And then we got to divide by 8. We get 156.25 equals r squared. And then square root, r is going to be 12.5 centimeters. Okay, if you have any questions on that, be sure to ask in class. I'd be happy to go over it. Number 11, Caitlin must build a sandcastle in the form of a square pyramid for a project as shown in here. I don't know why I wrote a B. As shown there. She bought 3 bags of sand, each containing 1,200 inches cubed of sand. Will she have enough sand to build the castle? So she bought 3 bags of sand. 3 bags would be 3,600 inches cubed worth of sand. So we have to see, would the volume of this pyramid be greater or less than that? So say we had less than that. That would mean she had plenty of sand. If we had more than that, she wouldn't have enough. So we'll talk about that. So the volume of this would be area of the base. So it's going to be 1/3 times like we would do a regular square pyramid. So it's going to be 25 times 25 for the base times the height. And that's going to give us 3,750 inches cubed. So to fill up the pyramid, we would need this amount of sand. Does she have enough? No, she doesn't. Since 3,600 inches cubed is less than 3,750 inches cubed, she doesn't have enough. Okay, number 12. Cylinder to the left contains 2 congruent hollow cones. If the cylinder's height is 20 inches and its diameter is 14 inches, find the volume of the solid. Cool. So the cylinder to the left contains 2 congruent hollow cones. 2 congruent hollows. Not a very good picture then. The cylinder's height. Okay. Find the volume of the solid. So this whole thing is going to have 2 cylinders. Let's say these are our cylinders, because they are. These are empty. My me. Empty. They are hollow. Hollow means empty, nothing in it. So we are trying to find the volume of this part. We're trying to find the volume of the red. So the trick is, we can just take the volume of the whole thing and subtract the volume of the 2 cones. And that will give us the red part. So let's do it. So the volume of the whole thing, so the volume of the cylinder is the area of the base times the height. So the cylinder's height is 20 and its diameter is 14, so it's going to be pi 7 squared. So that is going to be the area of the cylinder, which is going to be equal to 3,078.76 inches cubed. Okay, so we then need to subtract the volume of the 2 cones. So let's first find the volume of 1 cone, and then we multiply it by 2. So 1 cone. 1 cone is going to be 1/3. 1/3 of. Is it going to be 1/3 of the cylinder? It is, or isn't it? It isn't, because you see the cones are here. They're not through the whole thing. So this is 1 cone. So the volume of that cone will be halfway. So it'll be 1/3. Right? The volume, no, sorry, the area of the base. The area of the base is still going to be the same. Times the height. And the height in this case is going to be half of the total 20, which is going to be 10. Okay, so that is going to be 1 cone. So remember, we wanted the volume of 2 cones, and these 2 cones are the same. You can see that. So we just multiply by 2. And that's going to give us 1,026.25 inches cubed. So to find the area, volume of this region then, we need to take the volume of the whole thing and subtract the volume of those two cones. So we do the volume of everything to be 3078.76 minus 1026.25, and then we get 2052.51 inches cubed. And there we go. That's it. If you guys have any questions in class, I'd be happy to help you, or you can email me. Okay, see you.